Hello, this is Daniel from speedcubing.org, and in this video I'm going to introduce you to the basics of 6x6 solving. So to start off, what 6x6 should you get? Basically there's no debate really. There are three main 6x6s, Aoshi GTSM, X-Man Shadow and MGC 6x6, and basically these two are bad. The MGC 6x6 is the best 6x6 for pretty much everyone. Some people still like the Shadow because it's just got a bit more of a stable feel. The Aoshi GTSM is basically just a worse version of the MGC 6x6. So yeah, get the MGC 6x6, and it's cheaper than both of them anyway, at just £18 at the moment on speedcubing.org. So yeah, get it. So the first step of solving a 6x6 is to simply solve the centres, just like any other big cube. It shouldn't be too difficult to figure out, assuming that you can already solve a 5x5. Just find things like this, and then put them together, and then repeat. So here, 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 and then keep inserting them just like you would on any other cube. Now once you've solved 4 centres, it becomes a bit more difficult if you've never done it before. So what I would recommend you do is, on the top layer you solve one middle bar, like this for example. So here we have these two pieces here, and insert them in like that, and then solve one outer bar here. So in this case you can do it by this piece here and a T-shape here, and then you're going to want to solve a bar here, so like that, and insert it in. Now you've got last two centres case, and you can do all sorts of things with this, but I would recommend you solve most of this bar like that, and then you've got a commutator. So what we do for this is we have this piece here, and then do 2R U prime, and then I would just do middle flick there, but then I guess the notation is 3R 2R prime U 2R prime U prime 3R prime 2R, and then that solves that. I'll put the algorithm on the screen. So for the next step, you're obviously going to want to solve the edges. I recommend doing these purely on the M slice, but a lot of people like to do them on the E slice like this. I have no idea how that's fast though. And essentially it's just a mix of slice, flip, slice, and inserts like that, just like on a 5x5 really, but you've got 4 pieces per edge. So for the final 4 edges, it's pretty much going to be purely slice, flip, slice until you have it solved. So here we have these, and this is flipped, and that piece is there, so we can do that. Same here, but you only have 2 pieces, so slice, flip, slice, and then that other piece is there, slice, flip, slice. So in this case, we don't appear to have parity yet. Now, but if on the last edge you do have parity, then leave it until OLL, because if you do it now, you could end up getting another parity later on, so you should save it all for OLL. Now, if you do have parity, however, you can't really be completely colour neutral. You're going to have to solve a colour cross that's opposite one of the colours of the parity. So in this case, yellow is opposite white, and blue is opposite green, so either yellow or blue. So I'm going to choose blue here. Now we've got the cross just like normal. This is pretty much just like normal 3x3, except what you're going to find is that the colour scheme is wrong, which doesn't really matter too much. If you want to try and avoid it, go ahead, leave a 3x3 in front of you or something so you can check, but it doesn't really matter too much. Just do 3R, U2, 3R prime, 3L prime, U2, 3L, and then you fixed it. If you find that they're oppositely incorrect, as you can see from the F2L here, then do 3R2, U2, D2, 3R2, U2, D2, and then that will fix. So now just finish off F2L like you normally would, and here we have our parity. So you can see here that to get a normal OLL case, we will have to do the outer parity and not the inner parity, because if we did the inner parity, we'd have parity here. So do parity algorithm, just like on 4x4. I shouldn't need to explain this to you. And then you have a standard OLL case and can go straight into PLL, except PLL parity, which obviously you already know if you're watching this video, and then PLL. If you get an OLL case like this, then obviously you're going to have to do the inner parity, and that's why you should rate, because otherwise you may have to do it twice. So here, just do your standard parity AL or something similar, but with inner moves instead of outer moves. And then standard OLL and PLL.